The section on many u-subs is absolutely essential. What that refers to is when you have a choice of u which is linear. So, for example, let's say I had the cosine of 4x dx. Do this one in your head and think, what is my choice of u? My u is the stuff, it's the 4x, and du is 4dx, blah, 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 blah. In the end, what number gets pulled out? 1/4, right? And then we have the antiderivative of cosine of u, which is sine of 4x plus c. Now, I could give you a whole bunch of these. Let's say I did the cosine of, let's say, 7x dx. Well, do you see that the only thing that gets pulled out, because u is this linear term of 7x, the du is just going to be a constant, the reciprocal, 1/7 sine 7x plus c. Another one still, let's say I had the cosine of x/5 dx. Linear term here. The number that gets pulled out is going to be 1/1/5, or simply 5 sine of x/5 plus c. So these are endless. Let's do some over here. Let's do e to the 3x dx. So my choice of u is this linear 3x, and the number that gets pulled out is a 1/3, and then e to the stuff plus c. I'll keep doing a bunch of these. E to the negative 7x dx. That's going to be simply negative 1/7 e to the negative 7x plus c. Let's say we had e to the x/4 dx. That's going to be 4 e to the x/4 plus c. You need to be able to do these because sometimes, as you will see in a moment, sometimes it's just too laborsome to go through the entire u substitution process when I can get to the answer real quickly. Here's another one that qualifies as mini u sub because my choice of u, 5x minus 1, again is simply linear. So my answer, 1/5, is going to be pulled out, e to the 5x minus 1 plus c. How about this one? Our answer is going to be negative 1/10 cosine 10x plus c. How about this one? Boy, that's an ugly yellow color. Anyway, mini u substitution, negative 1 is going to be pulled out. So these should be nice and easy for you. As long as your u is a linear term, then you pull out the reciprocal number to be the coefficient out front. So let's do a differential equation. As I instructed in lesson 1, we're going to say that dy equals 3 e to the 2x plus 6 e to the negative 3x plus the cosine of x/4 and multiply that by dx. And then I'm going to take the antiderivative of both sides. The antiderivative of dy is y, technically plus c, but that'll be just brought over and combined. Then here's where we do some mini u subs. Let's see if we can get this entire antiderivative without actually showing any work. Do you see that this is going to be 3/2 e to the 2x? Then this is going to be minus 2 e to the negative 3x. And then this is going to be plus 4 sine of x/4 plus c. Now we'll use our condition, y equals 4 when x equals 0. So we have 4 equals 3/2. E to the 0 is 1, minus 2 e to the 0 is 1, plus 4 sine of 0, which is 0, plus c. The arithmetic will show that c equals 9/2. So we have our solution. Y equals the answer displayed in the yellow box. In our next differential equation, we have f double prime equals, and so we first want to find f prime. So f prime of x is the antiderivative of f double prime of x with respect to x. So that's the antiderivative of 3e to the negative x dx. This is a nice and simple antiderivative, so we have negative 3e to the negative x plus c. F prime of x equals negative 3e to the negative x plus c. We're going to use our condition for f prime, so this will be 1 when x is 0, e to the 0 is 1, plus c, and so c equals 4. F prime of x is equal to negative 3e to the negative x plus 4. Now we have to find f of x, which is the antiderivative of f prime dx, which is the antiderivative of negative 3e to the negative x plus 4 dx. Another mini u, if you want to call it that, 3e to the negative x plus 4x plus c, with our condition that f of 0 is negative 1, so negative 1 equals 3, e to the 0 is 1, plus 0 plus c. In this case, c equals a negative 4. And our final answer, f of x equals the answer that I have in the box. 18 is a tricky one. Believe it or not, this one qualifies as a mini u sub. You might recognize this as 1 over 1 plus something squared. That would be 2x quantity squared. Now that looks a lot like, do you feel it? Inverse tangent, book of memories, but I have a mini sub. U equals 2x. Now it's a mini sub, so I don't need this work, but I'll just show it anyway. 2dx, dx equals du over 2. That's telling me that I'm going to pull out a 1/2, and I'm left with 1 over 1 plus u squared du, and you should have this committed to memory. This is the inverse tangent. So 1/2 inverse tangent of u plus c, or 1/2 inverse tangent of 2x plus c. We could have skipped right to that if we recognize the mini u sub. Last one, number 19. Press pause now. Okay, you should be back from pressing pause. You should have tried some things, and perhaps you were in a jam. Remember, on the examination, I'm going to put a question where you might feel you're in a jam, and if you're in a jam, expand. This one is not as easy as the other one. I'm actually more leaning towards the easier one, but let's take a look how this one might work. So I need to expand this. So the numerator, if I expand that, you should know this is going to be e to the 2x plus 2e to the x plus 1. That's the numerator expanded. And then we have the denominator. But then this can be simplified. See, this e to the x can act as the common denominator to each of these terms here, giving us, well, e to the 2x over e to the x is simply e to the x. And then plus 2, because the e to the x's will cancel out in that middle term. And then we have plus 1 over e to the x, or e to the negative x. Aha! Now, this is nice and easy. So my answer is going to be e to the x plus 2x minus e to the negative x plus c. Ironic that I might end the lesson on u substitution with one that did not require a u substitution at all, except perhaps if you want to argue that this was a u substitution. But I might just call that a mini sub. Goodbye.